All right, guys. So I'm going to choose just a few of these examples to complete for you. Um, Give me just a moment to find what I'm looking for. Okay, let's start with example 3. Example 3 is asking us to find a simplified form of the difference quotient. And if you remember your difference quotient, that was when you had your f of x plus h minus f of x all over h. So I need to take this f of x function here, and I need to apply this difference quotient that I have written in red over to the right. So I know what my f of x is. What I do not know is my f of x plus h. Okay, and literally all that means is I'm going to take the expression f of x, and in the place of x, I'm going to substitute a x plus h in its place. So instead of having a x cubed, I would now have a x plus h cubed. So I have my f of x, which will go here. I have my f of x, and my h just stays in the denominator. So let's just take what we have and plug them in where they belong. Let's see if I have a bigger marker. I don't know if it's a little bit bigger. Not really. So my f of x plus h will be the x plus h cubed minus my f of x, which is x cubed, all over my h. I'm going to come over to the side here, and we're going to simplify this just a bit. Now, this first part here, the x plus h cubed, what you want to do is actually expand that, which means multiply that out so you can see all the individual terms in there. That way, if you have an x cubed, goes along with that one, a common term that I can add or subtract, then I'm able to do that. So let's actually multiply that x plus cubed out. Now, a lot of us have trouble remembering, you know, there is a shortcut for multiplying or cubing a binomial, but if you can't remember that, we can break that up and rewrite that x plus h cubed as x plus h squared times x plus h. Okay, so what I'm going to do, what I've highlighted in yellow over here, I'm bringing that to the side, and I'm going to actually expand that over to the left. And then I'm going to take what I find that x plus h cubed to be, and I'm going to substitute that back into my expression. So this right here that I'm highlighting in green, that is what we call a difference. It is a difference. No. No. Let me erase this. What I am doing there is I am squaring a binomial. Now, there's a pattern for when you square a binomial. So let's go over to all the way to the left. Anytime you have a binomial in the form of a plus b squared, once you square it, the expanded version will always follow the form of a squared plus 2ab plus b squared. That's something that you need to remember to make life a little bit easier for you. So what I have written in green or blue, what I have written in blue here that is highlighted in green, if I follow this pattern I gave you over to the left, the expanded version will look like x squared plus 2xh plus h squared. So that I'm highlighting right now is equivalent to x plus h all squared. But what I have to remember to do is still multiply that by x plus h. Now, now I have to use my distributive property. I mean, technically that's what I was doing all along. I just gave you your shortcuts to kind of cut a few steps out. But your distributive property here, let's pick a color. Let's use purple. What I'm going to do first is I'm going to multiply each one of my terms there by x. So that will give me x cubed plus 2x squared h plus xh squared. Then I'm going to come back and I'm going to multiply, let's use pink. I'm going to multiply everything by that h there. And I like to stack my terms, my common terms, my like terms, so that I can combine them really easily. So if I multiply h times x squared, that's going to give me x squared h. If I multiply that h by 2xh, that would give me a positive 2xh squared. And h times h squared gives me an h cubed. And if I combine my like terms there, that would give me x cubed plus 3x squared h plus 3xh squared plus h cubed. Come on, work with me. All right, so I'm going to highlight this in yellow because what I did is I expanded that x plus h cubed and found that this is what it is equivalent to. So I'm going to replace it. I'm going to replace the x plus h cubed with the x cubed plus 3x squared h plus 3xh squared plus h cubed. I will highlight that again so you understand that that is all the same thing. It's just written in a different form. All right. Um, and I'm going to bring my x cubed, just drop it down, the minus x cubed, and we're going to divide by h. Now, once you get to this point, what you want to do is combine like terms. And once you get here, once you combine like terms, the only terms that you should have left in that numerator are terms that include an h. For example, let's pick a red where we can see this. I have x cubed, and then at the end I subtract an x cubed. So I'm just going to cross those out. I don't have any other common terms or like terms up here. But what I notice is that each one of these include an h. That will always be true once you get to that step. If that's not true, then you did something wrong and you need to go back and check your work. So that leaves me with 3x squared h plus 3xh squared plus h cubed all over h. And now I can divide each one of these terms by h. In other words, subtract 1 from each. Take away 1h from each term. So this h is just going to be gone. I'm going to reduce that down to the 3x squared. I have h squared divided by h, which just leaves me with a plus 3xh. And then h cubed divided by h leaves me with h squared. And that is it. That is your final answer. That right there is the simplified form of the difference quotient for f of x equals x. Now moving along, let's see what else we have. Example 4 here is asking us to find the same thing. I'm asked to find the difference quotient. I'm asked to find the difference quotient for y equals 3 divided by x. So we're going to use the same process, follow the same steps here. I know that if I want to find my difference quotient, I have to use f of x plus h minus f of x divided by h. That's the format. And what I have to find individually is I have to figure out what my x plus h is. And I have to figure out, determine what the f of x is. They gave me my f of x. That's just my function. So I can just plug that in. But I need to determine what my f of x plus h is. So my f of x plus h, I would get that by taking my x and replacing it with an x plus h. So take your known parts here. I'm going to highlight this in yellow so you can see where my pieces come from. They correlate. The colors correlate there. And I'm going to take each one of my parts and I'm going to substitute them in where they belong. So I have 3 over x plus h minus my f of x, which is 3 over x. Then I'm going to divide that by h. Let's bring this over. Come on, work with me. All right, so I have a rational expression in my numerator, meaning I have fractions up here. I have 2 of them. That's not what I want. Excuse me. So what I'm going to do is I'm going to combine those fractions. I have a shortcut here that we're going to use. It's kind of you are combining, you're getting a common denominator and combining the fractions all in one step. And the way that works is by multiplying this way first, always. 3 times x gives me 3x. And because my sign here is a minus, I'm going to say minus. Then we multiply the other way, and you have to apply that distributive property. Or better yet, we'll just say 3 times x plus h. We'll do it that way so you don't get confused. All over, and then to get that common denominator, what you do there is you multiply your two denominators together. So that's going to be x times x plus h. And then I'm going to just put all of that over h. Now I've got to simplify this numerator, and I've got to try to reduce this. I need to write this in simplest form. So what I would do first is take that -3 and multiply that out by applying my distributive property. So that's going to leave me with 3x minus 3x minus 3h. Remember, you are distributing that negative along with that 3, divided by x times x plus h all over h. And if you pay attention to your numerator, you have a 3x minus 3x, and what that leaves you with in your numerator is just a negative 3h divided by x times x plus h. But I'm going to stop there and I'm going to do something a little bit different because I can't leave this rational expression in that form. I can't. That's not simplified. But what I see here is I see that I have a rational expression up top, which is that the 3x minus 3x minus 3h divided by the x times x plus h. But I also have a rational expression in my denominator, which is the h. Okay, it doesn't really look like a rational expression, but you guys agree that if I put that h over 1, I now have something in the form of a fraction, right? So if you think way back, you were taught that when you are dividing two fractions, um, what we do algebraically is we keep the numerator the same, which is what I did here. And what I'm going to do is change my division sign to multiplication. Then I am going to flip that denominator, which will now give me 1 over h. So now I have my colors still coordinated, so you can see what my numerator was, and now my denominator flipped. And now I can multiply these together. When you multiply fractions, you multiply straight across. So that would give me negative 3h over, I can put xh x plus h. And the h come from right here. And I'll make sure you see that over there. Okay. And if you pay attention, I have a h and an h in my numerator and my denominator. So I can reduce that fraction a little bit more. And that leaves me with a negative 3 over x times x plus h. And that is my answer for example 4. And I think that's it. So if you guys have any questions, just shoot me an email and let me know.